Thank you, everybody, for coming to the RoanokeValley.net user group. We're a user group that meets the first Thursday of every month. Sometimes it's in person like this. And we've been practicing with our recording of some of these events. And then we always have our virtual ones that's always recorded. We have those throughout the year as well. So we try to mix it up and have a good balance of both. But no matter what we do, we always have great speakers. And today we have Kevin with us. But before we get into that, quick few announcements. Sean, I'll let you lead with the coffee and code.
All right, yeah. So we will be doing a coffee and code at the Milk Mountain Coffee in Roanoke on Starkey Road, October 25th. So that is the fourth Saturday of this month, from 10 a.m. to 1 p.m. And it is a come as you are, bring your laptop if you want, or whatever else you want to do, socialize or just work on your projects. But it's just a nice chill opportunity to meet other members of the RV Nug community.
Awesome. Thank you, Sean. Alex, did you have anything?
Yeah, so as some of them mentioned already, Nova Code Camp is Saturday, October 18th in Northern Virginia. It's you can go to novacodecamp.org for that. Also, the RBTC.tech has the Emerging Tech Conference, and it's on October 30th and 31st at Hotel Roanoke. And so it's a local one. So
What happened in the month of October? A little further out, but a premier one. I'll get to you in just a second. Little further out, but a premier event that you want to sign up as soon as possible. Hampton Roads Dev Fest, which is a fantastic conference, and sign up for that. I think the sign-ups opens.
So literally, I haven't pushed the website yet. The only person who knows is Alex.
Oh wow! Okay, insider knowledge, guys. Should we like bleep this out from the video or?
No, leave it in. It's
Okay.
Yeah.
Well, you heard it here first, guys. It's going to be February 27th, Hampton Roads Dev Fest.
Yep.
All right. On.
I have a call for action. Relay for Life is organizing a fundraiser next year. It's probably going to be in April. What we want to do is a virtual duck race. We have some ideas on how to set that up. And we have some ideas on how to set up a fundraising website for Relay for Life. It's childhood cancer. We're trying to raise some money. Normally the Roanoke Valley raises about $100,000. Trying to top that this year. But we'd like to have people who are interested in helping set up the website to accept donations, etc. We can do something with coffee and code if people are interested there as well. So if you're interested, reach out to me either in person or on our Discord, which is on rv.org/Discord. You set that up? There is a link.
There's definitely a link.
Yeah.
Click on the link.
Yeah. And before the meeting, Ron came to me and said, make sure you advertise our brand new website that Sean helped build. And I think you've done some of that advertising yourself. But do check our new website out, rvnug.org. Definitely class act there, Sean. Thank you so much for redoing our old crufty website there.
Yeah, and just also to say on our new website, we do have links to Discord, links to our YouTube channel, links to the Meetup group, and also you can sign up for the newsletter, which right now is mostly just reminders about when the next meeting is.
All right, guys, thank you so much. All right, without further ado, we have Kevin Griffin with us today. He's going to be presenting on traits of stable production application by Kevin Griffin.
I'm 100% going to change that title because I have screwed up that title more than once myself. So that is going to get changed in the future.
I was helping prove points earlier.
Yeah. Ron, should I mute myself?
I think all that's post editing, right?
I want to make sure I'm not like overstepping the other recording. I've been muted. Oh my god. You muted me.
Oh, you did?
No,
Oh,
yeah, it's
me?
fine.
I'll be quiet.
Yeah, I need to change the title, so.
Sure, okay, what is the new title?
I have no
Kevin, I'll
idea.
let you speak it.
I have no idea what the new title is. I need to think about it. You're all helping me actually debug this talk. So you're getting the alpha version of this talk. I don't know what it's gonna look like in the future, but
No problem.
when it's much better in the future, you can go, I saw that when it was crap.
Again, this is
And
gonna be the second
this
thing
will be the
here
night.
tonight. You've seen here first, so.
Exactly.
Privileges. So Kevin is an author, teacher, mentor, and consultant focusing in software development. He is also a 16 time, this is like keep growing. How far is this gonna go?
I've actually taken the number of times out of my bio, so I don't have to update.
That's funny.
Yeah.
So 16 time Microsoft MVP. So 16, is that 16 years in a row?
Yeah.
Oh, that's amazing, Kevin. Specializing in ASP.NET and web development. As the owner of SwiftKick, a software training and service company, Kevin specializes in helping businesses push their technology stacks into the 21st century. You can often find Kevin speaking at conferences, meetups like this, and user groups nationwide, and blogging at consultwithgriff.com.
Griffin works too.
Oh,
Yeah,
cool.
I bought, you buy all the domains to cover every single use case because people are people. Yeah, so that works.
Brilliant. Thank you, Kevin, for
My
coming
pleasure.
over here.
So 16 years Microsoft MVP. I started speaking 17 years ago. 17 years ago. First speaking engagement, Roanoke Code Camp, 2007.
6.
Yeah, 2007. So,
WPF, I remember the talk.
I don't know, anyone here knows Robin Edwards? She's the one, Robin still in this area?
I believe so.
Yeah, I just like speak a
She's-
ghost
Mhm.
name into, yeah. See, every time I come here to speak, I'm disappointed she doesn't come say hi to me. And we're just gonna add another year to that list. So, yeah, 2007, Robin said, hey, we're doing this Roanoke Code Camp. You should come speak. And I think I did a talk on WPF. I was really fresh. And yeah, that just started everything. So I love coming to Roanoke just because this is where I got started. And really need y'all to do a code camp.
Website is still up.
The website's
I heard there's one in Hampton, DevFest.
Yeah, that one don't count, because I have to do all the work for it. So, yeah, it's nice to come back and hang out with y'all. I've been here, I really don't know how many times. So 16, 17 years speaking, I probably have been here 15 times. So as a part of the user group. So I'm happy to be here. Have a conversation if y'all want to hang out afterwards. I think we're going somewhere for a little bit of time, talk about anything in here. So this is a talk I started developing a couple of months ago. And I had done a workshop a year or two ago with a good friend of mine, Kendall Miller. And we talked about building battle-hardened .NET applications. So if you're going to push anything out into the world, which is a big deal, what should that app have trait-wise to survive? And we did that over a one-day workshop, and we had tons of questions and some people going, I learned so much from that. There were so many things I didn't think about. It was really enlightening to me. And this is all material I'm sitting back going, I thought this was supposed to be common knowledge. And the thing about common knowledge is it's usually not as common as you expect it to be. So I took a lot of the highlights of that workshop, put them into a talk. And yeah, so I'm interested in any all feedback that you have on this, anything you might want to add, things you might argue with me against, that's fine too. But everything, starts with the story. And this clicker is not going to work for me at all, is it? There we go. I love a lot of things in life. One of the things I love most is sleeping. I hate scenarios like this. And you tell me if you've had a scenario like this where you're sleeping sound and you're on call for some project and all of a sudden the phone rings. Oh man, this sucks. There we go. The phone rings. Say, hey, oh my gosh, something's broken. We need you to come fix it now. And you go, all right, I'm up. You go and take care of the problem. And it's fine once when it starts becoming a habit, it gets really annoying. And every time a website's down, depending on what industry you're in, there can be a couple different things that happen. You get that call, the payment system's down. You get that call, customers can't purchase anything. I see advanced auto shirt. Like if customers can't buy stuff, how much does that cost the company every minute if you're online or in the store? We're losing tens of thousands of dollars per hour, which seems like I'm being a bit flagrant about, but sometimes it's more than that, depending on the company. The one I love, we don't know why it's down. It's just magic. And how are you supposed to solve complex problems like I don't know why it's happening at 2 o'clock in the morning? That's a 11 o'clock in the morning problem, not a 2 o'clock in the morning problem. The thing I love, all right, that's Alex's product. I don't know how to fix Alex's product. So do we wait for Alex to come back or do we call Alex to fix the problem? Because we're losing $10,000 an hour. What do we do? I hate all these scenarios and I try to build and architect systems where this isn't a problem for me or for anyone else on the team. So this is really a set of tactics for preventing situations like that. Some stats that I like to throw out. There was some research done in how much would 1 hour of downtime cost an average company, and that turned out to be $843,000. That's a lot of money for 1 hour. If you're a developer on a team that's dealing with constant issues, 83% of us say we experience burnout just because we're dealing with constant fatigue of fixing outages and whatnot. A average developer who goes on call gets two interruptions per month, which means 2 times typically that in a month that phone is ringing at 2 o'clock in the morning. I like to go for 0 times a month. It also means you find yourself in these situations, the phone's ringing twice a month at 2 o'clock in the morning. You don't stay at that position very long because you only have so many months that you can do something like that. So we find software engineers tend to not stay around very long, just a little bit over 1.5 years. All right. And we already did the intros. Yeah, Microsoft MVP. I talk about .NET, I talk about Azure. It's one of my favorite things to do, and building and architecting business systems. I've worked in a variety of different industries, on a lot of different types of projects as a consultant. I've picked up a lot of little techniques because I hate those 2 o'clock in the morning calls. And I've worked on projects where that's a major issue. If something goes down in the middle of the night, someone's calling me to tell me that I need to get up and fix the website. So we're going to talk about traits, specifically traits that turn your fragile applications into rock solid production systems. And they're going to seem pretty straightforward if you've been doing this for a long time. If you're new, hopefully you learned something along the way. But let's jump into trait number 1. Major aspects of the system don't belong in one's head, only one person's head. That's the Alex problem. We're calling it the Alex problem. So system goes down at 2 in the morning. Someone says, the system's down, take a look. Well, that's Alex's system. Only Alex knows anything about it. Alex only knows stuff about the database. Only he knows which Azure server it's hosted on at the moment. That becomes a problem because then no one can come in and fix the system when it goes down. The other thing that we need to be really careful of, and I think about this all the time as a consultant, is what happens if poor dear Kevin gets hit by a bus. All that information is gone in an instant, and it's probably going to hurt the whole entire time. So how do we prevent a case where if for some reason poor Kevin gets hit by a bus You know what? Round of applause for AI, right? Like, that's an amazing prompt, and he did exactly what I asked it to do. I don't know why you would say software developer on the bus, but
It's the competition, I think.
yeah, it's you know, but you know, it kind of got me. I think I gave it my image and said, "Oh, this is what Kevin would look like as a cartoon."
That kind of bus exists in South Korea.
What's that? Oh, this says software developer.
South Korea, there's a designated like shuttle bus that take
That's true,
developers
yeah.
to their,
Oh my goodness. Okay.
Oh,
yeah.
Wow. So if I found myself in South Korea accidentally and I got hit by a school bus, how do we prevent the system not being catastrophic? Client that I'm with right now, if we were having this conversation maybe 6 years ago, that was a likely case. Kevin was the only person working on the project. And if Kevin sadly met his demise, that project was dead because no one else knew the system well enough. It would take time, money, energy for someone else to come in, see what did Kevin do here? They would say a couple choice curse words because Kevin doesn't write the best code all the time. And they would eventually get the system running the way it was. But that's not an overnight fix. That's a multi-week, multi-month fix. So I ask questions like this. With my team. So I have the guy on my team, his name is Wade, and someone will come into our team and they'll say, hey, actually dealing with this morning, we're having some issues with configuration. What do I need to do for X, Y, and Z? And my response, which I actually forgot was in the slide, was ask Wade. And the real answer should be, you should go check our wiki, check our Confluence, check our documentation. All this stuff should be documented somewhere. So we use it as a learning point. Anytime someone asks a question, if it's not already written down somewhere, we make it a point to go answer the question. So there's a reference to always be used. Check the wiki. There's things out there called run books. We create these. We don't necessarily call them run books, but we do this to a degree, and they're recipes for how to do different things in our system. For example, if I'm doing a new deployment, we have a process that we go through. We do a test in our development environment. We push something to our pre-production environments, and then eventually it gets promoted to our production environment. And there's steps along the way whenever we do one of these things. So we have a document that outlines what you have to do. So if someone new comes onto the team, we can give them the documentation, and they should be able to walk through the documentation and do anything in the system that's critical. If we need to go in to one of our systems, perform any sort of cleanup or backups, there's documentation for that stuff. We have a system we use for logging, and one of the things I have to do every now and then is I have to go kick the server because it messed up. I wrote documentation for doing that, and one day, just as a test, I gave it to a person on my team and told him, go through and see if you can do it by yourself. And what worked really well was he got about 60% of the way, ran into a missing piece of information in the document, came back to me, asked me a question. I updated the document, then he could continue along his way. And every time we've done that, the documentation has gotten better. Let's see. Yeah, update the documentation. That's a rule that you should follow. More importantly, as we update the documentation, we always test our new developers on it, anyone who comes onto the team. I always like to say, we brought on a new person on the team. We had them committing code by the end of the first day, just because pulling down the code, setting up their environment, getting the first compile done, and making a change and deploying it to the system was all so well documented that there was no guesswork. She just pulled it down and she did all the steps. Gotta make sure it stays updated. There's also something to be said about commenting your code. I think this is so much easier to do now than it was maybe a year ago because AI can write most of your code documentation for you. But even though AI can change the documentation and make it so much better than anything I would write. I think if I wrote the code comment for this, it would just say, calculate the area of a circle, nothing else. But AI can come through and write all the other junk for you. That's really useful as long as it's updated. And it always goes back to update the documentation. Even AI is bad at this. You'll have AI rewrite some code and it forgets to update the documentation. Oh,
Also, double check what AI writes about your code.
oh shit. AI is 100% correct all the time. Look at the school bus. So one of the things we do, and I put this on my list every couple weeks, is to go through, brain dump anything that I've been working on, make sure that I have documentation on it, review those documents as I need to. And I'm always bad about this. Something will come up. I'll see our support channel, and I instantly always want to jump on those tickets because I want to help the customers get back into the system, do what they're going to do. But usually I'll take a step back. I'll let someone else on the team take the issue and run with it. And that always finds a gap in our documentation and our knowledge on the team. So we use it as a learning opportunity. I'll update documentation, or we'll figure out there's an issue that needs to be fixed. We'll put it into our Jira and we'll fix it later. But the end result is you get everything out of one person's head, because the best thing that happened to me having a team was I went on a 2-week vacation to Italy, and I told them, I'm not touching the phone. I'm not touching the computer. If anything goes down, oh well. If it's only Kevin can fix the problem, I'll fix it in 2 weeks. And I left the country. And thankfully, nothing major broke or couldn't be handled by the team without Kevin being there. So that's a win in my book. All right, trait number 2. You can't fix what you can't see. We're going to talk about telemetry. Specifically, we're going to talk about 3 types of telemetry. You have logging, you have metrics, and you have tracing. And they all kind of mean different things. You might be doing one really well, but not the others. And this is really just a progressive game to try to get better and better. Yeah, let's go one at a time. So logging, I think we can all do pretty well. And that's just having a detailed log of what's happened in the application. So we use logs pretty pathetically. We use them a lot. So we log everything. And we can go in our logs and we can walk through the status of an application at any point in time to see what it was thinking and what it was outputting. So this is from Seek. Since this is a .NET group, we use serial log to take .NET structured logs and we put them into Seek, SEQ. Just really easy to review all the logs, everything that's happening in not just one system, but a dozen different systems. They all log to the same place. There's different types of logs, and this is the thing I don't see developers doing extremely well. We always assume there's just 2 types of logs. There's info, and then there's error or critical. As you're building out a system, you should be logging with all of these different logging types. Things like trace data. Trace data is just, trace and debug is just general information you probably don't want to track in production, but would be really useful if you ever had to turn it on. Information we use probably the most often. I throw everything under information, even when it should be debug or it should be trace. Warnings we use seldomly, only when we don't really want to use info and there's really not enough for an error. We'll use warnings. Errors and fail critical we kind of use simultaneously. These always get logged. That's why they're in red. because you always want to know when something bad happens in the system. What's the nice part about using the different logging levels is when you're in production or in one of your different environments, you could technically at runtime control what level is being logged to your log system. So if you're in production, you might only want to log warnings and higher, but you get that weird issue. You say, well, I don't know what's going on. Let me turn on more debug information. Technically at runtime, you could turn on all the way back to debug and get all those logs in real time without any code recompiles. That's happening. I thought it was a cat for a minute. I'm like, what?
That might be a
It kind
critical
of sounds
error.
like a cat. Like, yeah, yeah. There it goes. Up two. Oh, uh-oh. Fatal. I hope not.
Hopefully not.
But we've done that a couple of times where we'll go in production, say we need more information. We flip logging to the debugger to info, and we get that critical debugging information we need in our production systems without having to recompile or redeploy the application. And that's really the important part. We want to be able to do all this work without having to redeploy your system. So here's an example of code where it's just a lot of different types of statements. I'm tracing something, I'm putting out some debug information, I'm sending a warning, I'm putting some just general information. And this uses structured logs. So in .NET, you use the built-in logging provider. And if you say something like, starting order processing flow for order ID, and you pass order ID as a parameter, in the structured logs, that metadata for order ID gets abstracted out. So let's say you're logging everything, so trace, debug, warning, whatnot. They all have order ID attached to them. And let's say that order ID is 552. Well, I could go into my structured logs. They show me all the logs associated with order 552. And it would give me all those logs because it can filter directly off the metadata in all my log entries. One thing I don't put in here is, so for logging information, that's not really important. There's a lot of different places to log to. In .NET specifically, I log to Seek. I love Seek, but there's others out there. People are probably using Splunk or Datadog. In the past, I've used Loggly and Papertrail. The one place you never want to log is, well, two places you never want to log. You don't want to log the files. Files are IO intensive. They're slow. Standard out is slow as well. Never log the standard out. They'll just slow down your application. So always log to some sort of external logging provider. All right. After logging, you have metrics. Metrics are fun. So they tell you how often stuff happens. So metrics here. How many requests am I getting per second to this API endpoint? How many requests are failing at this API endpoint? How long does it take an API endpoint to process a request? Those are all metrics. And we're probably tracking these for every endpoint that you're running in different applications. You can also do this for backend processes. I run background services, and they track how long it takes the background service to run. It gets more minute than that. So if I'm cleaning up blob storage in our Azure instance, I might track how long it takes the entire process to run, but then I'll track how long it takes each individual file to clean. You can get as minute with it as you want. And the whole goal of this is that as you collect more data, you can start to figure out when things are not running as they should. So if you have an API that's deployed and you have a very important endpoint, let's just call it update. So your update endpoint typically takes, let's just pick a number out of our butt, 100 milliseconds. Takes 100 milliseconds to run that endpoint. Awesome. Adds fastest, it might take 80 milliseconds. Adds slowest, it might take 3 seconds. All right, we know those metrics just from watching the time over different periods of the day. Well, if that endpoint all of a sudden starts taking 10 seconds or 12 seconds or 15 seconds, we might want to set up an alert on that because something is wrong in the endpoint because we're taking longer to process a request than how we processed it in the past. That's bad. That's good information to know. It's bad that it's happening. From an error standpoint, if my update endpoint maybe it has 5 errors per 10 minutes. Things break. I mean, we're all human. So not everything works every single time. But sometimes we just accept this is going to fail 5 times every 10 minutes. Well, if it starts failing 10 times every minute, that becomes a point of alarm because now you're throwing more errors than you are typically used to throwing. So let's go take a look and see what's happening underneath the scenes. Duration is another one. So update. All right, I already talked about duration. So excuse me. But then you can come back to rate. I think I'm in the wrong order. I should fix that. If my update endpoint gets 1,000 requests per second, cool. Well, then I see these other things starting to kind of go off the chart. I might go back to request rate and see, oh, it's doing 10,000 requests per second now. What happened? Is it an issue on my side? Is it an issue on someone else's side? Do I need to institute rate limiting? There's a bunch of questions that you can ask just based off of looking at metrics.
Actually, the opposite may be true as well. If you normally get 1,000 requests per second, then all of a sudden you get 5 requests per second.
Absolutely.
That may be also an indication something is wrong.
Something broke. Yep. A lot of different tools for this. We use Application Insights for most of it because we're on Azure, but I've also used New Relic in the past. And open telemetry is becoming a thing that a lot of people are talking about. I think it has great potential. I think the tools are a little janky. So it's not always going to be bad. So yeah, a lot of different tools here. The other thing you might want to track is business metrics. We're dealing with this right now. We're doing a beta for one of our products, and we're tracking how often people do certain things in the site. How often does someone log in? How often does someone go to the reset password page? How often does someone bring up our navigation bar? How often do they hover over certain things to go to different areas of the site? What type of searches do they run? And we track all these different metrics because as we push this beta into production and becomes the real thing, we want to know what should we dedicate our time to optimizing in the future. If we have a section of the site no one's going to, and we have a feature that no one's using, I'm not going to care about that feature at all. We might remove it altogether, but we want to know that unless we have the metrics for it. So we collect the metrics. And we've been testing a tool called Full Story to collect some of those metrics on the client side. It works really well.
Full Story, is that something you add to your application or is it running in?
It's a service. It's a service. You add their library to your page, and it tracks everything when the customer goes to it. So you can associate the customer to a session, and it'll track their session over time and say, well, this person did that, this person did this, and you can make it anonymous. I don't believe in anonymous. I want to know what everyone's doing. I want to know who they are. But you could, if you had to deal with silly things like that. But we can set up events. So anytime someone does something in the site that triggers an event in Full Story, and we can get metrics on that.
That's F-U-L-L, right? Not F-O-O-L.
What's that?
That's F-U-L-L, right? Not F-O-O-L.
I have no idea.
Full, is it F-U-L-L?
Oh,
Story.
F-U-L-L, yes.
Okay.
Yep, sorry. Ryan, why are you speaking in code?
Is that just creating a / matrix endpoint, or is it doing anything else? I mean, it obviously collects, stores, catalogs, matrix while it's running, I'm assuming.
Yep.
It's all in memory.
Well, it's reporting all this. So Full Story is a service. So it's reporting it all to the Full Story service.
Oh, so is
Is
it
it
back
kind
end as well?
of like Hotjar?
Yeah, I think I haven't looked at Hotjar in such a long time, but I think it was very similar to that last time I looked at it.
Most of the things I see, at least, we're doing is in our services, we add things that will generate a like slash matrix
Yeah.
endpoint, and then we'll have Prometheus or whatever go scrape it.
Uh-huh.
Or don't scrape it, that's fine. You just do an endpoint, then something else can scrape it at whatever interval it wants, or
Yep.
don't scrape it, that's fine. You just have an endpoint.
Yep.
The full story, I guess, is more of a full story, right?
Yeah. It's more of a polished product.
Gotcha.
Yeah. Stuff like that. I don't want to spend the brain power trying to assemble my own tool set.
Does it go as far as like tracing how the user moves?
I can watch an entire user session.
Oh my God,
Um,
that's awesome, because,
So
yeah,
where they move the mouse.
where they
um,
stop moving the
click,
mouse, that they
yep.
don't know what they're doing, yeah.
It can also detect, I don't know how it does it. They call it aggressive sessions. If someone's getting frustrated with your app, they say they can detect that by mouse movements. So I guess if you get frustrated, you like shake the mouse more. I mean, don't we all like just throw the mouse across the room? So yeah, it's fun to watch a customer use the product.
Yeah.
And see what they do.
No privacy issue?
Huh?
No privacy issues?
Maybe.
You don't care, okay.
Mm-mm. We don't have a public application or not
Gotcha.
a public product. So people who sign up for our product agreed to some very, some good terms and services. that
I'll
they-
cut it out of the video.
Yeah,
don't
that's
worry.
fine. I haven't told you what the product is. All right. Last thing to kind of talk about, and I don't do this too heavily, is tracing, and that's following a request through all the different things that it might hit. So sometimes when an application breaks, it's not necessarily a you problem. Like Alex, it's never a you problem. It's always a Togo problem, as far as I know. But sometimes it's a database problem. So how do we track where the problem occurs in the system? Because if a request is coming into our API, it goes and checks the cache and then hits the database and the database fails. This is going to record in our logs and our metrics as a failure at the endpoint. So if I'm coming in and starting my investigation, I'm just going to see the API failed. I should go through and do a little bit more investigation and see, oh, that request came into the API. That request then went to the cache and then try to go to the database. The database is where the failure was, and I can track that through the entire life cycle of anything happening in the app. We can do this as well for slow services. If for some reason a request comes in, and I'm typically doing, what do we say, 100 milliseconds? All right, well, that means it hit the cache, the database, and worst case, some database didn't have what we needed, so we went to an external web service. Well, that's a slow service. So it took our normal 100 milliseconds request and turned it into a 30-second request. Well, how do we know that unless we go through the entire life cycle of a request coming into the system? So this is really useful. Basically means you have to do a little bit of legwork to track through all the different systems. This might be one server, this might be another server, that might be another server. You can set up the I don't have the word. I'm totally lapsing on the word. There's a word to track the request through the entire life cycle. Let's just assume I know that word and I said that word right now.
Observability,
What's that?
observability.
No. So observability is the idea. Let's just say it's like a telemetry ID. So
Trace ID.
trace ID. Yes, there's another term. I just can't remember what it is. That's all right. It's not a big deal. So we get a trace ID. We'll go with that. Trace ID, when the request starts, that trace ID goes throughout the entire system, and I can go into my logs or into my metrics. I can look at a particular trace and see how long did that spend in different aspects of our application. I use Application Insights for that, but there's a variety of different services that all do the same thing. Again, open telemetry is trying to be the way to solve this problem. So you see like Jaeger coming up as the open source way of solving this problem. I haven't played with it heavily. I'm an application insights guy. Trait number 3, environment-specific behavior without code changes. We're going to talk about configuration. And this still bites me, actually was biting the team today because they made some, they did some bad stuff. So first and foremost, never put configuration or secrets into your source code or your source control. I don't think I have to explain why that's bad, because if anything happens to that, or if you need to change anything, source code is the worst place to put any of this information. All right, I have a bunch of rules here. So first, I think everything in your application should be a configurable option. Let's start with the basics. The basics being your database strings, your connection strings. So we talk to multiple SQL servers, we talk to a Redis cache, we talk to Azure blob storage. These are all different configurable options that we have. And we call them primary SQL server, or we call it primary Redis server, or we call it Azure storage. They all have defining names, but the value we don't know until runtime because it's in a different place than our source code. Web services. If I'm debugging against, if I'm developing against someone else's web service, I might have a sandbox I talk to in development, but then a production server when I'm in production. Well, I don't have to have different settings in source code, depending if I'm in debug or production. I want to be able to just set a configurable setting for this. Things like intervals. So we have background jobs that check email accounts, and we have an option, configurable option for check this email account every 5 minutes. And when we'll push that in production, maybe we want to change that to every 1 minute. Well, it'd be nice to just go into our configuration, change a 5 to a 1, and just be done with it. If it's in the source code, I now have to go change the source code, go through our PR process, deploy it to our dev environment, then test it in our pre-production environment, and then push it in production. There's so many steps in between just changing a number that we shouldn't have to do. As we're developing new features, we'll set enable, disable based off of the environment. So sometimes in development, we might turn certain features off because of reasons, but once they're in production, we want to turn those features on, or vice versa. Some stuff we do in development that we don't want to do in production. We set those all as configurable options. All right. The benefit of having everything configurable is that you can stand up as many environments as you want. And go back to the first trait. Not everything's in my head. A new developer comes on our team and they download the source code. They maybe grab a copy of our database schema, but then they set up their configuration. And their configuration is in the documentation. Set up local SQL server. Set up local Azurite for blob storage. Set up local Redis cache. We actually set them all up as Docker containers. So they don't even have to go install anything. They just run a script. Sets up all the containers for them. And we tell them these are the defaults if you follow our instructions to a T. So within 10 minutes, they can have a full stack for our environment and just be ready to go. Now, sometimes silly things like SQL Server, if you're installing that locally, your server name might be different than someone else's server name. So that person goes into their configuration, their local configuration, changes the server name, and it works great for them on development. It doesn't impact anyone else down the line. I have at least one story of someone changing something in code that should have been configuration, pushed it into source control. It accidentally gets into production and breaks production because they changed the configuration in the source control. So we don't do that. We put everything into configuration. I mentioned earlier, you can change environments without redeployments. We've done this more than once. where we'll go into production, we'll turn a feature off, and it just restarts the app, but that feature is now turned off for everyone. And that takes 10 seconds versus the tens of 20s of minutes that it would take to redeploy the application. All right, there's a lot of different places to put configuration. The easiest place is in a file. So for .NET, this is your app settings.json file. You can also have app settings.development.json. You can get more advanced. You have app settings.development.local.json. This is an entire talk all on its own, just configuration. Some old school folks might remember INI files. If you're running in JavaScript, you might use environments env files. They all do the same thing. They're key values. So for a certain key, when it's found in code, will return a value. More so than configuration files, we don't use configuration files in our external environments. So in our development environments, in our production environments, we use environment variables instead. What's really nice is it's only for that environment. Production will always have the production SQL server. That will never be on any of the other environments. No one on the team has to know the value. So if there's anything secret, it's tied to that environment. We don't accidentally mix up the configurations. That has happened more than once when we were using configuration files. So environment variables all the way. There's also configuration services out there. We use Azure App Config. We're trying to move as much as possible to Azure App Config because it's like environment variables, but more distributed. So we have several cases where, I don't know, we have half a dozen API services that all share like the same 10 configuration options. Well, if we put them all in the app configuration, they can all just talk to one server, get their configuration. If I need to make a change for any reason, say I'm rotating secrets, I can go to app configuration or Azure Key Vault, and I can rotate my keys, and that's done for all my applications, not me now having to go to every single server and change the environment variables. That gets tedious after time. Every major cloud provider has one, and there's also some open source third-party solutions that do the exact same thing. They're all just glorified key value stores that protect your data. Trait number 4, reliable, repeatable, rapid deployments. Just ship faster and make it more repeatable. How many of you have deployment day? No, no one has deployment day. It's just whenever you feel like it.
Yeah,
Let's go live.
right before vacation, that's a good time.
Right before
So-
a demo.
Yeah.
Sunday night, Monday night, Tuesday night, Wednesday night, but
Yep.
not Thursday, Friday, Saturday, or Sunday. Well, no, Sunday night's okay. Sorry, just certain days.
Who deploys on Sunday?
Sunday night, you're still there Monday.
Who is there to press the button?
Is that part automated or?
Well, I mean, we do our deployments at night, so
Okay.
Sunday night is a good day because Monday, everybody will be in the office, so things are on fire.
Yeah. So what you want to avoid is the case where you have deployment on the Friday before someone goes on vacation. I have been this person, not by my choice, but by the client's choice, where they said, you really need to deploy this today. And I said, yes, but I'm out of town next week. So who's going to support it when it breaks? And because it's not going to be me. And what ends up happening is the phone goes off. I'm on vacation. And
Why
Kevin
would
ends up
you
fixing
deploy
it.
something that breaks?
Huh? Oh, because I'm a consultant. I get to charge more if it breaks because I can come back and fix it. Doesn't matter if I caused it.
Notice he said when.
When, yeah. It's never going to work perfectly. So what things can we do to avoid cases like this that cause the most problems? This is a .NET crowd. How many times have we been told over and over and over again, never hit right-click publish on a project? Like that is just not how you're supposed to do it. However, it is sometimes the easiest way to deploy a project just when you need to just ship it. Don't do that. Manual processing or publishing in general is bad. If someone has to go perform the process, you've made some mistakes, because that's when bad things happen, because people are generally good until they make a small mistake or something goes wrong. That's why I'm a huge advocate of CI/CD. Yep, repeatable processes. CI/CD, continuous integration, continuous delivery. Basically, there should be a script somewhere. There should be a process that knows how to deploy your system, any aspect of your system. And anyone in your team who's trusted should be able to run that process. Doesn't always need to be Kevin. It can be someone else. So I'm a huge fan of CI/CD. Our process is simple. It doesn't need to be complicated. I use GitHub Actions for all of our CI/CD. A lot of folks use Azure DevOps. A lot of people use TeamCity and other processes. They all practically do the same thing. They remove the manual aspects out of it. So with our GitHub Actions, a couple things happen so this one's called deploy critical functions. Literally, that's what it's called in the system, critical functions. It's because this is stuff that's not allowed to go down. So we have it siloed from other functions that are not as critical. But this also only gets deployed once every year because it never needs to change. It does the one thing it does very well. But if we ever have to redeploy it, there's a process for redeploying it, even though this might run once or twice a year. What our GitHub action does, it checks out the code, it recreates the build environment, it does a complete build, it runs any tests that are associated with the project, it makes sure everything's good to go, and then it stages everything for production, sure that comes up and then it gets swapped in production. This is always manual, so in GitHub Actions, you have workflow dispatch. There's no automated process that will run this GitHub action. It has to be a person go in and say run. We have other GitHub actions that are automated. If something gets committed into our master or main, it automatically kicks off a development build. And if we're ready to push something in through production, there's processes for doing that as well. But everything's repeatable, and every single time we create a new project, we have to associate it with a GitHub action. And actually, what I'm doing on Monday is we're deploying a new service, and I have to go test the GitHub action for it. Testing the GitHub action is the worst part of this process. Who's ever deployed a GitHub action? All right, you don't just deploy a GitHub action once. You deploy a GitHub action 20 times because you screw up one little part of it, and you have to go back and fix it. The only way to test the GitHub action is to redeploy the GitHub action. In some environments, you have pipelines. So I can do an initial build and it goes to a build environment, and then I can promote that environment up through a chain until it eventually goes to production. What's really cool about this is I'm never pushing anything into production that hasn't been tested or validated by members of the team. It always has to go through the process. Things like Azure DevOps do this extremely well. I've seen very complicated setups. I've seen simple setups. I'm a huge advocate of this for larger teams. For our team, we don't do it like this, but this is nice because you can go through, you run and test. If it fails in test, well, that code is never going to see production because you'll go back, you'll fix whatever needs to be fixed, and it'll go back through build and test and security. You go back to our previous trait. These all have their own separate configuration, so we can test everything individually in its own silo. All right. Yep. The general goal of everything is to reduce human errors because humans make a lot of errors, intentionally and unintentionally. Brings us back to that first trait. If Kevin gets the call at 2 o'clock in the morning and is fixing an issue, do you want Kevin to also have to remember all the steps to do a production build? it would be much easier on Kevin to just go, oh, that was a blah, 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 fix it, deploy. And the script takes over and does all the hard work for me. Okay.
Should I slide maybe now say human/AI?
Yeah, that's a good point. Yeah. On our team, anything AI generated is the responsibility of the human who prompted it. So it still could be human error. All right, automate everything. Yep. So a lot of tools for this. I use GitHub Actions. GitLab has its own CI/CD. DevOps, code pipelines, cloud build. They all do the same thing. Oh yeah, so hosted versus self-hosted. TeamCity is what I used to use a long time ago before I think Azure was even a thing. I think we played with Jenkins once and said no for different reasons. There's a lot of tools to solve these problems, kind of what I'm trying to say. I love this quote, something I was reading, hope is not a rollback strategy. We also need to make sure that if anything goes wrong, that we can quickly revert back to what was last known working. Environments help a ton with this, so if I go from my dev environment to test to UAT, to pre-production to production, let's say a bug gets to production and it's critical. Well, we can always just swap back to our last environment. It takes a couple minutes, but we can always do that swap. We don't have to go back through a build and deployment process. As your organization gets bigger, as your products get bigger, as your teams get bigger, this needs to become more complicated. But you always want to have that strategy of, all right, something critical went wrong. How do we go back to where we were before? Now it gets more complicated if you're changing things like databases and you're doing migrations. There's just no easy solution to that. Like even any framework with its migrations up and migrations down, anytime you have to touch a database, I usually say rollback is not an option. Like we just have to push forward with this, but it all depends. All right, trait number 5, graceful degradation, because stuff fails. Usually not because of your code, usually because of Tolga's code. Something bad happens, Tolga messes up. You need to be able to fall back and deal with the different errors. And these are just design patterns. The Murphy's Law is anything Tolga writes will probably break. Anything that
There is proof for this. This is
there?
provable statements, yeah.
Anything that can go wrong will go wrong. Let's just design against it. So there's design patterns that we can use in code. So bring this back to code aspect. There's a lot of them. I'm just going to touch on 3.
Kevin, I want to add a corollary to the Murphy's Law. There is another law that says if it's still working, it hasn't gone wrong yet. It's Murphy's second law.
Okay, Murphy's second law.
Yeah.
All right. I don't think I've heard that one, but I agree with it. The retry pattern, circuit breaker pattern, and the timeout pattern. Some of this stuff is already built into things you might use every day. Some of this you might need to write yourself. Really easy to do in .NET. Oh yeah, there's more than these. Actually, if you sit down with Claude or ChatGPT and just talk about design patterns around resiliency, it's going to say, here are 12 design patterns I think you should care about. And you go, no, give me 3. These are the big ones that I have used on multiple projects. Retry is the one that I think everyone's most familiar with. If you try to talk to a web service, that web service may or may not be working at that point. Well, if it's not working, we should retry. How much time before we retry? How many times should we retry? This is all logic of the retry. And then a max number of retries. So if I want to try to hit that web service only 3 times, 4 times, after that, throw a hard exception, throw the hard error. But until then, please retry for me automatically. This is an example in Poly. So Poly is an open source project that has a lot of these different resiliency patterns built into it. You just have to use them. A lot of the .NET framework uses Poly underneath the scenes. It is a great project. I'm friends with the maintainer. A lot of thought has gone into this over the years. But here's an example that seems complicated, but what it's doing is defining a policy. So that policy says, I am going to attempt to do something. If it fails, I'm going to retry up to 3 times. And between every retry, I'm going to wait a little bit of extra time. And this introduces what's called jitter. So instead of just trying after 1 second or 2 seconds or 3 seconds, it might be 1.2 seconds or 3.5 seconds. It's going to vary just a little bit. And there's logging, so you don't have to worry about that. But we can take this policy, store this away somewhere in our code, and then when we want to use it, we can just say, well, use our retry policy. Let's call a method, and that's just going to do an HTTP call. Now, I show this as doing retry, but HTTP client will do retries for you automatically. So you don't necessarily need to do it this way. But if you're talking to your cache, if you're talking to the file system, you could just take the same retry policy and use it in a lot of different scenarios. So one line of code to do all this work. Circuit breaker, if something's going to fail, you want to prevent it from having cascading failures because maybe a service is completely unhealthy. I've used this once and only once, but it's think about it like the circuit breaker in your house. If it's open, it means you can do everything you need to. If it breaks, oh, sorry, no, I got my notes here. So if the circuit breaker is closed, it means all the requests can pass through without problems. Failures might occur. If a failure occurs once, that's okay. If multiple failures occur, say 3 in a row or 3 at all, that's going to close the circuit, so it's going to protect itself. When that happens, the code's going to wait a period of time, 30 seconds, and then it's going to reset. And it's going to go back and keep doing what it was trying to do. This is useful if I'm talking to an API and say, I'm calling this API once, but if I needed to call that API 100 times, well, if they're having an issue, I don't want to keep trying to call that same API over and over and over and over again. I might want to break, send something back to the user, reschedule the task for later. Circuit breaker is a good way to take the let's call it the jitter out of potential failures from this endpoint. Knowing that stuff might happen, and if it does happen, we can automatically try to do it again a little bit later. And then timeout. We've all probably seen timeout more than once. If we're performing a task, how long should we wait before we consider that task dead, good or bad? Poly has a timeout policy, which says I'm going to go do something, and I'm going to wait a period of time. So here we have 3 seconds. If it takes more than 3 seconds, it's going to cancel itself automatically. This is in a lot of .NET stuff by default, but if you're writing your own services and you need to have a timeout built in, you just write your own. And so you have pessimistic and optimistic. I actually wrote the notes here. So forcefully pessimistic, cancel the operation after 3 seconds. Works even if the operation doesn't respect cancellation tokens, which we're not talking too much about. This is always going to enforce the timeout. There's another strategy called optimistic, which relies more on this cancellation token that you're passing. Says that optimistic behaves a little bit better than pessimistic does, but if you need that hard timeout after 3 seconds, 10 seconds, 30 seconds, pessimistic is probably what you want to use. And Poly does an amazing job in documentation. They also have at least a dozen other design patterns that you might be interested in. I just covered 3 of them. All right. Trait number 6, this, I believe, is the last one. Proactive detection. Goes back to our monitoring, our metrics, but we should be tracking the health of our applications or all the time. The big conversation is health checks. This was added to .NET many, many years ago. And what essentially that you do is look at the health of your system, however you define it. So for our system, we know it's healthy if, well, first if the endpoint responds, that's good. But we'll look at our database, we'll look at our caches, we'll look at file systems and stuff like that. If we'll run small tests against all those systems, if it fails for any reason, that's cause for alarm. Or if something's slow to respond, we might be healthy, but our health might be degraded. So there's 3 different types of health checks depending on your environment. For the most part, we only care about liveliness for the stuff that we do, but in different scaled environments, you might care about readiness and startup. So if it takes a couple minutes or seconds for your application to get warmed up and get going, you might have one check just to see, did the application start as you expected it to? And then you have another check to see, is this application ready to serve requests? Is it ready? And then is it just generally alive over the lifetime of it? That's all I have for health checks. So health checks as a whole talk all by itself, but return something similar to this. This is not there's a .NET way of doing it. There's a dozen different ways to do health checks. There's no unified format for it. There was an RFC a long time ago saying this is what we think a health check should look like. That actually never passed. So this is just however you want it to be. And .NET will let you change any aspect of this health check request, which makes it really difficult if you're passing it into, say, like Kubernetes checks it one way, Azure checks it one way. You just have to define what you think it should look like. And ultimately, how do you want it to be responded to? All right.
You really need health checks if you have matrix?
I know what you mean by matrix, so I don't know the answer to that question.
Trying to think, like, or I guess our services have the /matrix endpoint. So if you can't reach it, the matrix platform like Griffin will mark it as down.
Got it.
So you know it's down. It's not healthy. I'm trying to think if there would be benefit of having a separate health check on top of the matrix endpoint.
Probably not in your case. Like in our case, where we're looking at health. So you do have either up or down, but then you might have degraded. So it might be up and running, but not running at full capacity, because maybe your database is running slow for some reason. That's
the matrix would tell you too. So I guess it's
yeah.
Okay.
Would it also account for if you have 3 instances of your web servers running and one of them is down, would Matrix pick that up as well?
The way the scraper works is it'll detect the different instances and it's supposed, but I don't know how, if it's behind a proxy, how it would connect to each one. Does the health check though? Would the health check be any different?
Degraded health at that point because you only have 2 of your 3 services up. Even though that is the same service. I'm looking at something like a Kubernetes cluster or something.
Yeah.
Are you using something to expose the health check?
.NET does it.
.NET does it. Okay.
Yeah, .NET has health checks built into it. And there's a lot of really good open source extensions to that. So you shouldn't have to write any code to support health checks.
So I wonder if it's giving the whatever server you end up connecting to's health check, not the whole thing either. Like if one of them is down out of 3.
And you just happen to hit that one.
Yeah,
so
you
like,
would still. Well, if you have a good load balancer, you'd just be hitting that one anyway.
Yeah.
But you would see the spike of requests because if one instance is down,
That's it. Yeah.
so that's your average
Right.
goes
That's
up.
what that
so
could be a telltale sign.
yeah, you'll get alarm. Also, it can be up, but the database can be down. So the health check, if you're just checking the posts, will be okay, but it's not okay.
Mhm.
But something again like Grafana would return it. That's actually a good point. Is Microsoft way of health check checks if it's just up? If it's up and like the database is up?
Yep. So in .NET, so I have an entry here that says SQL Server. What ours does is it connects to our production SQL Server and runs a very easy query against a critical table. So something that doesn't use a lot of processing power is just return first row in the table. If that succeeds, that we consider that healthy. And if it returns in a certain amount of time, which should be milliseconds, we consider that healthy. Now, what's happened is something else hitting that database uses a lot of processing power, slows down the entire database. Our health check call makes this simple request, takes 30 seconds to respond. So it comes back as degraded, it's not unhealthy, it's degraded because it still responded, but it responded in 30 seconds and not 10 milliseconds. And we do that for every server that we care about. So everything in here, these are all the critical systems that our application relies on. Redis, our Azure Blob Storage. This is 4 lines of code in our application that expose this data. Mostly because other people wrote the hard code. So checking Azure Blob Storage, someone wrote the extension methods to make that easy. Same thing with Redis. Our Forms is the external web service we own. That one's actually not critical. If that one went unhealthy, it's not a big deal. I think we actually have a rule that says that can be unhealthy and the entire application can still be healthy. But it's just good for us to know because we'll track this and see, oh, Forms went down, someone goes off and tweaks. But yeah, it's like 4 lines of code to set all this up in .NET nowadays.
So where does it go? Like, do you have alert systems? Are you just watching the graphs?
So it depends. One of the places we use this is we have Azure Container Apps that do talk to health checks. And if we're loading multiple container instances, if one container instance reports unhealthy, we will actually just shut that instance down and start a new instance. Those are much simpler health checks. Those actually aren't checking our databases or anything like that. Those are just making sure, am I alive? Am I alive and responding to data? Because they're performing different cases. Azure App Services will use your health checks to help alert you if something goes wrong. Every service is different because, like I said, it's not a standard. So it's just whatever you're using it and how you're using it. But you can very well create your own service or your own endpoint that tracks your health endpoint. And if it sees anything's unhealthy, or if the total status is unhealthy, it could send you an alert.
So what's the difference between readiness and startup?
Oh, I didn't put that in the slide. So startup is just, are we done with initialization? Like maybe, I don't know, if you have initiation sequence that has to occur before the application is considered alive, that's startup. Readiness is it's able to handle requests. So depending on it really depends on the service that's talking to it.
Readiness then?
What's that?
Wouldn't startup be before readiness then?
It would be, yeah.
Okay.
So yeah, my order's wrong. If you like Azure Container Apps will let you specify 3 different endpoints depending on what you want to check. So if you have a startup health check, if it doesn't see its startup within a certain period of time, it considers it dead, it kills the process and tries to start it again. And it'll do that until the readiness checks or the startup check succeeds. Once that succeeds, it'll say the app's up and it's healthy, and it's going to look for readiness if you have a readiness check defined to see if it's able to handle requests after that point. So it helps you narrow down where the potential problem in your application might be. It also helps you self-heal in cases where you could heal. I think like liveliness and readiness kind of mean the same thing. We use liveliness in cases where I have containers that are not, they don't expose an API. They're just running their own background services. So they might expose, well, I take that back. They expose one endpoint, the health endpoint, just to know, is the background services, are they running the way that we expect them to? Because there's been some times where it starts up and startup's complete, but it doesn't actually ever run the thing it's supposed to do. And that health check would fail. And we need it to fail and kill itself and alert us if it's a continuous thing, or it self-heals and it just goes about its day.
Sounds like you'd be working with Docker where you didn't expose the port.
Say that again?
Sounds like you'd be working with Docker and you didn't expose the port that
Yeah.
the servers are running on.
Alrighty. All right, last trait, separating concerns. This I actually threw this in here because I was doing this talk before and I was trying to promote another talk I was doing. But the big thing is just don't mix your background work with your user-facing services, your APIs, your websites. It's very easy to write some code that goes off and does a whole bunch of things. We process order in our database, but then let's send the email, and then let's go update the inventory, and then let's notify the warehouse, and then eventually send the OK. This will really throw off your metrics, because if any of these pieces take a long amount of time, the user's just going to sit there waiting for a response. This is just don't do this. And no one really does this, but I say that, but then I see it. So, all right. The way to really solve this problem is that you should put all this stuff into background services. So this is Hangfire as an example, where I process the order, save something to the database, but then I queue work to be done afterwards. This might take 10 milliseconds. Save to the database, queue the work to be done, get back to the user. This background job exists somewhere else, and it'll do the work. It might take 30 seconds to process all the order information. Sometimes it might fail because maybe they can't send the email because the email service has gone down. There are a whole lot of reasons things can fail, mostly because Togo wrote the code. You do this all externally. Let's see.
What was that? What were you using there to
Hangfire?
Hangfire?
This is an example of Hangfire. Yeah.
What is Hangfire?
Hangfire is a background job service for .NET. I've used Hangfire. I've used Quartz.net. I've used hosted services. I actually have an entire talk I do just on the difference between those 3 or 4 ways to solve the problem. So I will not do tonight, I promise. But the reason I talked about Hangfire was because I was doing a talk on Hangfire. And so I do have an entire talk on this that I'm not going to do. All right, so wrapping things up, there are a lot of different tactics. You may hopefully have a bunch of ideas that you want to take back to work tomorrow. Don't do it tomorrow, wait till Monday. The big thing I can say is don't try to implement everything at once. That'll drive you nuts. Try to implement one small thing at a time. If your logging's bad in your system, try to add some logging. If you don't have a place for your logs to go, that's not standard out or files, work on that next. And then slowly just add more things over and over again until you start hitting a lot of these points. If you are doing manual publishing, maybe write a script to do that for you instead of doing it all manually. Our goal is just become progressively better, not just becoming better overnight. All right, so next conversation is there anything you would add? But that's not a conversation for here. That's a conversation for wherever Alex is taking me. But thank you all so much for hanging out with me tonight. It's been a pleasure.